Hello everyone, this is a video lecture for pre-calculus. We'll be doing 5.5 today. I titled it GeoGebra. Now GeoGebra is kind of like Desmos. It's a website where there's calculators and all kind of stuff. We normally use it for statistics here, but here in pre-cal, we'll be using it alongside my math lab, like inside of it. There's problems on the homework that like reach out to GeoGebra in order for you to complete the problem. And it's, I can't describe it as well as you just doing it, okay? I have notes on how this all works, but what I was told between the making of my notes and the actual homework questions is that they've been flipped. So what happened at first was that I had all of these GeoGebra questions up front, but since that time, they have now been moved to the back. And so what I'm going to do right now is actually go into the homework, which I now believe is your question 1, 2, and 3, and then eventually we'll get to what I believe is like question like 10, 11, 12, and all that in just a few minutes, okay? Now, it's not going to be perfect, but I want to try to keep the order as best as possible. If for some reason GeoGebra is actually in the front, skip ahead or behind the video, and well, there you go, okay? So, what we're doing here is we're going to be graphing, okay? Now, the GeoGebra side of things is much more in depth, but here on the My Math Lab side of things, we're going to simply choose like A, B, C, D kind of stuff, okay? And so let's just talk about graphing for a whole minute, and then we'll jump into the problems. First off, we've got sine wave, so I'm going to do a sine x, kind of looks like this, okay? And let's compare that with the cosine, which I believe we're only doing the sine and cosine in this section. It looks something kind of like this. Now, what really is going on is that it keeps going on forever and ever on both sides, like this, and here and here. So these are very similar. The only points that make them different is where they start, essentially. And you can see here this is starting at 0, 0. But this one is starting up high, typically at 1. So that's at 1. This is always, well, basically at 0, okay? Now, this first chunk that I graphed is called a period. It's single period, and in this particular case, your period right now is 2 pi, okay? 2 pi. That's the standard period. Now, things are going to change whenever they give us different numbers, which will happen pretty much immediately. But right now, your base is 2 pi. So what I want to do right now is I'm going to just go into sine for just a second. Cosine is just a little bit different, but the same basics. I'm going to go into sine x, and I'm going to graph this much larger, and I'm going to label stuff here to describe what's going on. So right here at the end, we've got 2 pi. We start at 0, we go to 2 pi. I'd already said that. So what's in the middle? A single pi, 1 pi. And then a quarter of the way, pi over 2. And then over here, 3 pi over 2. Now, this is a number line, okay? This is like, x and y number line stuff. But if you were to graph this, I would say like in polar form, what you're doing is you're going around, right? 0, pi over 2, pi, 3 pi over 2. The point is that you're going around a circle here, and this is just the y values. Remember that sine is y, and then cosine is like x. Okay, so the height here is your y values. Okay, which is super in depth, and you don't really need to go that far right now. The point is that it looks like this. Okay, cool. So it goes up until 1. And it goes down until -1. Now, I know it's not the scale anymore because technically right here is 1.57, and I don't think I've done the scaling correct, but it's close enough, and you'll have to bear with me, okay? All right. So I got the period. I got the, this thing right here, this is called the amplitude. Amplitude. Okay, amplitude. And your amplitude is just this amount right here. It's 1 to like the middle part of it, I guess, to the top, or the middle to the bottom. Now, it's always the absolute value. So in this particular case, I would say amplitude is equal to 1 because it's a 1 distance. It goes up 1 and it goes down 1, okay? Um, so that's one thing there. The period, like we've already said, is 2 pi. Now, all of these are going to change a little bit, and I'm going to show you how they change. All right, so we got the basics down. This is sine, cosine again. It just starts up high and then goes down low. So there's not really a lot of difference in amplitude and period and stuff like that. What I want to do is show you not just sine, but I want to show you the full function. So this is going to be A, I'm going to use capitals. I like capitals. A times sine of B times x minus c, and then all plus d. This is the big one, okay? So this is the basic up here. I mean, it's kind of like saying x squared. And now I'm saying 5x squared minus 7x plus 12, something crazy. I'm giving it more stuff, essentially. Okay, so let's talk about it. A is amplitude. A is amplitude. So whatever number you have there, that's your amplitude. Just make sure that it's positive. So you're going to have to say absolute value of it and all that stuff. B is, it doesn't really have a name as far as I know. I mean, it probably does. You got me as your math teacher. Hey, I don't give it a name. But I can tell you that there's a formula for it. Your period is equal to 2 pi over b. So if your b is a 1, then you put a 1 there and you got 2 pi. So that's easy stuff. But what if you had a 2? What if you had a 5? What if you had a 3 pi? So you would just put that down there and then would solve for your period. This C is your horizontal shift. And I often also call it your phase shift. There's probably a difference between phase shift and horizontal shift. I don't really care, honestly. It doesn't matter much to this class. And then finally, D is your vertical shift. And so that's going to be the up and down that you're going to change, okay? So there it is. Memorize it. Here we go, first problem. So I got 5, 5, 1 is y is equal to 3 sine of x. And they say, first off, what's the amplitude? Well, look at that. It's a 3. Good job. Hey, what's your period? Did I spell that right? Yeah, I did, I think. You can't tell, though. So this is a 1x. And so it's actually going to be 2 pi divided by 1 is 2 pi. Yep. That was it. That was pretty simple, right? And then they say graph this. And so here we go. I'm going to graph a sine. Whoop, whoop. There you go. Ta-da! Well, there's more to it, of course. I mean, multiple choice. So you're going up and down to 3. You're going to 3. And then way out here, again, is the 2 pi. You started at 0, you go all the way until 2 pi. Wow, I wonder what those numbers came from. So there you go. Pick this one. Of course, it'll keep going and going, but you're really just looking for that first little chunk that really makes it stand out, okay? If it doesn't have this, then it's not right. Okay. Next one. 5, 5, 11. I've got y is equal to 6 sine of 4 pi x. All right, so what we have right here is, we actually got two pieces here. Your amplitude is a 6. Very good. Your period is equal to 2 pi divided by 4 pi. Notice that was your b, right? It's the thing next to x. And so the pi's are going to cancel. The 2 and the 4 cancel a little bit, leaving 1/2. Now that is weird, but it doesn't make it wrong. So it's a sine, so we're going to start here in the 0, and we're going to do this, okay? But where are my labels? Well, this right here is actually at 1/2. It's always that number for your period. If you start here at 0, you go a full distance, so now it's 1/2. This right here is actually 6 and -6. Now, is this to scale? No, it's not to scale at all. Let's just say I made one to scale, okay? And so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's a 1. And I'm supposed to be doing this in a half. You ready? So, so to get to 1, I need to do 2 of them. I mean, I almost want to zoom in here and do it. Let me just try to zoom in and see if I can make this kind of funny for a second. You ready? Okay, so this, by the time I get here, I've already gone 2 revolutions. I mean, I can't do it. It's just too tight. So it's going to look like if it were to scale, but we're not really to scale here, fortunately. If my math lab's trying to make it to scale or something weird, just, choose the best one. But honestly, this is the way that we should be doing it so that you see more so what's going on. Okay, another one. 5,561. So I've got a graph, and they say find all of the equation from it. So it's doing this. Let me try that again. It's doing this, and that's a sine already. Just hold up before we go any further. That's a sine, okay? We started at 0. And I know, like, where's the cosines here in this section? I get it, okay? We're just doing what we're doing, okay? And it landed at pi, okay? That's my period. We'll start talking about it in a second. And then I got a 4 and a -4. So I'm going to ask you, what is the amplitude? And you're going to say 4. Yeah, it's right there. And I'm going to say, hey, what's my period? And you're going to say pi. Perfect. It's right there. But I want to know what b is equal to, because this is equal to 2 pi over b. I need to solve for b. And so I'm going to multiply the b, divide by the pi. B is equal to 2 pi over pi. The pi's cancel and leaves a 2. Now, that's not an answer they're looking for, but we definitely need it. And so let's set this thing up. On my math lab, it has y equals, and then there's a box. And we're going to have to type it all in. So first off, my amplitude's a 4. So put a 4 in the front. I said it was a sine, so we're going to put a sine. And because these are all so easy still, I'm just going to simply put like a bx and call it a day. Well, that's my b. It's a 2. You put an x in there, and you're done, okay? So all these things, all these components came from my analysis of the graph. Okay, I only have one more from the homework, and then my math lab homework, and then we're going to do the GeoGebra stuff here in just a second, okay? So this graph was definitely a little weird to me, and I'm going to try my hardest to make this thing work, okay? So it did something kind of like this here, and I know it keeps going forever and ever, but this is what we're looking at. I have a 12. This is at 6. And then I have right here a 4. Up here is a 12. And in the middle of that is an 8. Okay? All right. Whew. So first off, it says y is equal to what? What do we need? We need to say that this is a cosine. Notice that it started up high and then it went down low. Definitely not a sine. That is a cosine right there. So let's start getting some other stuff. I want to find my amplitude, and that's going to be the distance from here to here or here to here. Well, it looks like I'm going 4 distance, right? From 8 to 12 is a 4, and from down to here is a 4. So 4 is my amplitude. I'm definitely using a cosine. And then I need to put some stuff on the inside, like a b and all that kind of stuff. Okay, well, if you look here, this is your period, right? And that is equal to 2 pi over b. So if I multiply the b, divide by the 12, I get b is equal to 2 pi over 12. Cancel a little bit, simplify. Pi over 6 is your answer. And so that's pi over 6 right here. And then you put in x. Very good. And there it is. Now, I'm not done. It's not done. It's wrong. Well, it is wrong by just a tiny amount, okay? And I did this myself when I was doing the homework. I went through and I was like, I know I got it right. What's wrong with this problem? There is a vertical shift on this problem. Notice that my middle is right here at 8. It's not at 0. And so I forgot to put plus 8 as my vertical shift on the outside. And all that does is it brings it from like where it was right here and it shifts it up to 8. That's all it's doing, okay? Now it's working. Yay! All right. So that's the end of that section, kinda, okay? Now I want to go back and do these GeoGebra questions with you. Now, I don't know how else to label this. It's just like they don't have numbers like all the other states. They don't have those ID numbers. So this is like GeoGebra number 1, essentially. And I'll just start doing like number 1, number 2, and all that kind of thing because that's just what it looks like in my math lab. It doesn't actually have any ID stuff. Now, when I started doing this, I mean, I got freaked out. I was like, this is wild, man. I don't know how we're supposed to do this together. But after a while, you get the hang of it. There is a bit of a technical leap that you're going to have to make, but I'm sure you can handle it. So, it says that my period is equal to 2.5, and it's definitely a cosine. That's a B, and they just say fill it in. Okay, so here we go. If my period is 2.5, this is supposed to be 2 pi over b, and I need to solve for b. And I know I use the capital letters, not the lowercase. Whatever. So multiply, divide. We've already done this before. So b is equal to 2 pi over 2.5. When I put that into a calculator, and I mean the 2 over 2.5, well, actually, you know what? I'm looking at my notes. I did not do that. So give me a second. I'm going to say 2 divided by 2.5, and I got 4 over 5, and then you just slap a pi back on there. Don't put the pi in your calculator, because it'll just give you some weird decimal that nobody knows about, okay? Okay, so that's what I got now. Let's go and type this thing in. So here we go, back to GeoGebra. How are we going to answer this? Well, they have a big old box, and we type it in. So I'm going to type COS, cosine, and then I put the 4 pi over 5, and then I slap an X on there, close it, and then there's 2 buttons in the bottom here. I'm trying to remember what it is here. There's like save and submit, and then there's like check answer. So I'm going to write check, and then I'm going to say save and submit. So what I often do, I did this just a couple days ago, but I think you hit the check button and it'll say correct, blah, 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 blah. But it doesn't actually finish the problem. What you have to do is hit the save and submit for it to actually go through. And then there will be a pop-up that happens. And it'll say, you did really well, something like that. And then you need to like say next. And so after that, you click the next button. There's going to be probably a pop-up that happens in your browser, Chrome, Firefox, whatever you're using. And you might need to allow pop-ups for this thing to even work. So I would say look at the top of your screen, like up here, and it might say blah, 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 pop-ups, blah, blah, blah. And you have to like click a button to make it even work at all. All kind of technical issues here, okay, guys? All kind of technical issues. But just push through. Get this done. Ask me questions if you need to, and we'll get through it, okay? Now, after you click next, and it's whatever, it's like done, next, great, awesome, and then it just leaves you hanging. And you're like, what do I do now? Well, you have to like X out of the whole thing. You know how like in the top bar, there's like that like X up here? Click the X, bloop, and or something like that. You might have to hit close or something. There might be a close button somewhere. And then this pop-up thing goes away. Then you go back to my math lab, and it's gonna look like it's missing. It's gonna look like you didn't do any work. Okay, this is like, it freaked me out the first time I saw this, okay? I'm just telling you how it's just straight how it is. And so like, I don't know what to do. I just did the problem, and so I tried it again. I said like, do the problem again, and then I went through it, and the same thing. It's still not accepting it. What's going on? Okay, so what you have to do is on the side on my math lab, there's all these like question one, question two, and blah, blah, blah. And you're sitting on question one, let's say. If you click and you go on to question two, like next question, or like you hit the next question up here or wherever it is, I think it might be down there, then it will show the little check mark after you get off of the page, after you get off of that question. And so, again, it's just, it leaves you hanging, and then you move on to the next question, and then it says, "Oh wait, never mind, it's cool now." And you're left wondering, like, why? Why couldn't you just tell me that beforehand? So, you're gonna figure it out. I know you will, but it's very silly technology stuff. Okay, well now let's get back to what we were doing. So question 2, it says f of x is equal to 3 sine x, and they say graph it. Okay, so I'm going to show you my graph, and then you're going to replicate the best you can, okay? So here's my graph. Oops, there we go. There we go. So over here is a 2 pi. We have a pi, which is in the middle. And this is a 3 up here, and down there, that's a 3. That's a 3, negative 3. And there you go. There's my graph. That's what I got, and we're done. Check mark. Great. Moving on. Allow pop-ups, whatever you're going to have to do to make it work. So how is it working in GeoGebra land? And I'm trying to remember, because it's been a bit. I believe that there's these little sliders, and you have to slide them into the correct position. And so you make sure that's at 0, and then you like tick mark that one up and tick mark that one down and make sure that this one's aligned at the pi and blah, 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 blah. That kind of stuff. Just graph it. It's actually intuitive. If it were really terrible, I would have said something on my notes. But I think it's not bad. The very first part is like, it's technically like technical, but after that, these questions are actually not too bad. I've even found that they accept unsimplified versions of the answer, which is nice, so that it's basically very easygoing. It allows all kind of weird stuff. Like here, just as an example, I actually typed this in for my b instead of the 4 pi over 5, and it worked. So it will accept all kind of weird answers, and still, as long as they're equivalent. So that's kind of nice. There's some good things to it, okay? All right, so we're supposed to graph this one as well. Let me just give you a few, I guess, warnings. We got a negative in the front there, which is going to flip it upside down. We also have a negative right here, which this one flips it like backwards, okay? So this is going to make it go backwards, essentially. While this one here, it's going to flip it upside down. What might happen is that it might look the same as the original because of the 2 negative signs. Like double negatives, 2 negatives make a positive kind of thing. Not every time, but I believe that's what's going to happen here for the sign in particular. All right, so let's go ahead and extract some information. This negative pi over 3, rather, let's just do the pi over 3, is equal to 2 pi over b, and I'm solving for b now. Whoa. Pause. That's wrong. Wrong. This is my b. B equals the pi over 3, and so I'm looking for my period now, which is 2 pi over b. Okay, I caught myself. But you can see how easy it is to just, because like this is what we had been doing, and all of a sudden everything's way different now. So just watch out, take an extra second once in a while and say, oh yeah. So I'm going to take this and flip it into the numerator, and I got 2 pi over, and it's actually going to be a pi over 3. So here, watch this. Here we go. I'm going to be 3 over pi, basically. So when I flip it, the pi's are going to cancel, and I get a 6. So that's right there is my period. All right, let's start to graph this thing. Essentially, I need to go out to 6. And my normal sign would go like this, okay? That's, it's close enough. Okay, and this would go up to 3/4, -3/4, and cool. But that is not technically ish what the answer is. That's my original. That's without the minus signs. Okay. So what I'm going to do is I'm going to use red for this minus sign. So I'm going to flip it upside down. So and now it looks like this guy. Okay. Cool. Okay. Awesome. And then I'm going to use the blue for this minus sign. And so that takes this and it flips it this way. And so it's going to look like this here. Oh, man, don't go backwards on me. So now I'm at -6 over here, okay? Cool. But here's the thing. Do you see this blue right here? Let me just take this blue and I'm going to keep following it. And oh my goodness, it's a full sine wave. It's coming back to itself. Remember, because this keeps going, doesn't it? Doesn't this keep going? This original black that I had right here, it was the answer. Because again, like I said, 2 negatives make a positive. And I could prove this to you because sine is an odd function. The minus can come out, and there indeed is a negative 3/4 sine of the pi over 3x. Well, 2 negatives make a positive. There you go. So I basically got back to my original, which I had graphed. Cool. That doesn't work for cosine, just for sine there. All right. Well, that was pretty fun. Number 4. So they're just going to get worse and worse, by the way. I got a -1/2 cosine of -1/3 x. Pause. Notice that I have 2 negatives again, but this negative here does not come out. That negative disappears. Yep, because it's an even function, it actually just disappears. And I have that written in my notes. I actually have it written, disappears, okay? Now, this one here is going to make it upside down, that's fine. That's upside down. There you go. So that's fine. We'll contend with that in a second. But this guy's going to just go away. All right, so 1/3. B is equal to 1/3. And so, again, my period is 2 pi over B. So 2 pi over 1/3. You're going to flip that into the numerator. Oh, that's the junkiest arrow ever. When you flip it up there, you get 6 pi. Let me verify with that. Yep, there you go. So there's your period. So let's graph this thing. So my original, it's, cosine. It's going to look like this. This is just my original without flipping it or nothing. There you go. And I end up right over here at 6 pi. Yeah. Okay. And so then, again, this is 3 pi and blah, blah, blah. My height here is 1/2, and right here is a -1/2. All right. But it's supposed to be flipped upside down. You see that negative right there? And so what I'm going to do is flip it upside down. And there, that is your answer, okay? That's your answer. The red is your answer. I got 2 more GeoGebra questions. Oh, did I say that was number 4? This is actually number 5, but I don't think it really matters. Like, this is number 7. I don't know what to say. It's, I can't do every problem, but at the same time, I think it's a little mixy-matched anyways. Okay, so we got 2 plus 2 cosine of -pi over 2 plus 2x. I just really like red today, apparently. Okay, there we go. So let's like figure this thing out. This plus 2 actually should kind of go in the back. It's gonna be a vertical. I'm just gonna write up because it's going up. It's going up to. That's my amplitude right there. Amplitude. And this is all messed up. Okay. So I want to like take this and dissect it for a second. What I want to do is I need to pull this 2 out to the front right here. So it's going to be 2 times and then x and then a minus something or other to make this thing work. Well, the problem is that this is a pi over 2. and it's already negative. So that minus is right there, okay? And I would like to just put pi over 2 here, but that is not the case anymore. Whenever I factor out a 2, I need to factor out a 2 from this guy as well. And so I'm pulling a 2 out of the pi over 2. And you probably have not seen this in quite a while, but I am going to put down a pi over 4. Yeah, a pi over 4. Isn't that weird? So let's just back up for a second about why I just did that. The 2, when I just redistribute to verify, 2x, check. Whenever I put the 2 in here, the 2 and the 4 cancel, and it leaves a half. Check. So that is correct. It's just so weird. We're not used to doing it that way. So if I were to rewrite this, correctly, it should be 2 cosine of 2, and then x minus the pi over 4, and then on the outside the plus 2. That's that plus 2 right there, okay? Cool. Well, let's figure this thing out. My 2 is my b. That's my b equals 2. And so my period is 2 pi over b. 2 pi over 2 makes it just a pi, okay? So that's my period. All right, let's graph this thing. And so normally my cosine, cosine starts up high. That's my normal cosine, okay? And I should end up here at pi, okay? My normal amplitude is a 2 and then a negative 2, normally. But this time I'm shifting it up by 2. At minimum, let's do that. So this is now my new average, my new middle. And so I'm actually going to start up here at 4 and go down to 0. And so I'm starting up here at 4, and then I'm going to touch down here at 0, and then come back up to 4. So now that's my new improved answer. But yet again, I have this phase shift thing. And inside opposites, you're actually going to be going to the right by pi over 4. Now let's understand where pi over 4 is. Right now, this is pi over 2, and this is pi over 4. And again, this is 3 pi over 4. I'm taking my red, and I need to shift it to the right by this amount right here. This is my new starting line, essentially, okay? So here we go. I'm going to start right here, and I'm going to dip down and come back up to 4. Here we go. Do, 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 do. Do, 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 do. There you go. Same graph. Your green is your answer. I really hope you're not colorblind. I'm so sorry. I hear that red and green don't mix very well, and blues are almost invisible because they're just they're like the black. At least for me, I can barely tell the blue over the black. Okay, I have one more problem, and I just want to set it up. I'm not going to actually do it, okay? Because I gotta leave something for you, right? And you're like, no. So this is just a setup, okay? I've got sine of negative 4x minus the pi over 2 and then minus 1. And so I want to adjust this. I'm going to factor out a negative 4 to the front. Not right here, right here. It's still on the inside of that sign. And so I got negative 4, and then I'm creating a new set of parentheses, x. When I factor out a negative 4, I'm going to have something here. But I always want a minus so that I can see what kind of shift I'm going to end up with, okay? Now, I know it's not going to be simplified, but I don't really care. So I'm pulling out a negative 4, and it already has a negative, so I'm pulling the negative with it, leaving basically a positive behind. So I guess I will just change it to a positive, okay? I said I was going to leave it as a negative. Might as well just make it positive. If I'm pulling out a 4, remember I'm not saying put a 4 on the top here. I'm saying I had a 4 on the bottom almost. Pi over 8. I know that's really weird. Let's verify. If I redistribute, I get the negative 4x. And here I'm going to get a negative. Again, the 4 and the 8 cancel, leaving a 2. So that works. From here, you just do the same thing we just did a second ago, and you're done, okay? So that ends this lecture, finally. So I guess that's it. Thank you very much, and have a great day.